Welcome back to the Advanced Microcontroller series. So in this lesson we will learning about embedded programming and project creation with PICGenios board. Here is the agenda. Introduction of embedded programming, important terms, example, PICSimLab architecture, software installation. So what is embedded programming? So it is the process of creating specialized software for microcontrollers and processors. So that control devices, machines or systems such as automotive, airbag sensors, wearables or home appliances. So in this series, we will using these three softwares. One is MPLAB XIDE, then XC8 compiler and PICSimLab Simulator. So these are the software we need to install. Click the link. Then here MPLAB XIDE based on your system, download. Then MPLAB XC8 compiler. So here based on your system, download. Then PICSimLab Simulator, download and support on GitHub. Then here stable version executables download. Click it. Then so this is the latest version. This is the latest version. Assets. So here based on your system, download. Click it and download. So these are the software installation. And next is the important terms. So what are the important terms? Host, target and cross compilers. So host means a system which is used to develop the target. So here we using MPLAB XIDE. So this tool helps to develop the target. Target means a system which is being developed for specific application. So our target is PICSimLab. So here we using PICSixteen-F877A Microcontroller. Then what is cross compiler? Before that, what is compiler? Compiler is nothing but a software which is convert the code from high level language to the machine level language to understand the system. The cross compiler is the process in which we writing code in PC, that code will running in different systems. So that is in microcontroller. So an application used to generate code for another architecture being in another architecture. So that is called the cross compiler. So here we using XC8 compiler. And next is the code. So see here, this is the C code. What is the aim of this code? Why this code is written? So this code will print the value of X. So we will run this in our target board. So target is having OS or not? It depends on complexity of the work you do, the requirement of the project and many other factors. So here we learn low level language which is non-OS. So that is called the bare metal. Okay. Can we write like this? The same code? So our target is same, to find the value of x. So does target support this code? It depends upon the target mode. So it is good to know what target mode is, what it contains by architecture. So board architecture generally gives you overview about your board and its peripheral interface. So here we will be using PICSimLab Simulator. So PIC16F877A board. So let's see the architecture. So here it is. So here what we having? GPIO, temperature sensor, RTC, ADC, RS232. So many are there. So what is this? Input and some other output. So here you can see PIC16F877A microcontroller at the center. It is connected to. So what are the inputs here? So see the arrow mark which is giving to this microcontroller, GPIO. This is the input. I2C is the input. Then RTC or EEPROM is the input. Then LM35 temperature sensor is the input. Then ADC, buzzer, digital keypad, matrix keypad all are input. But here you can see the arrow which is given to the components from microcontroller, that is the output. So RS232, then LED, SSD, CLCD, these are the outputs. So some components acts as input as well as output. So here you can see in this code. So now we need to write the code for. Turn on the LED. So now here int LED, then LED equals to 1. Can I write like this? In this case LED turn on. LED turn on? No, it will not turn on. So what to do? We need to specify the address. So before that we need to use the pin number to connect the external devices. We need to know the pin. So how to connect? By using port, right? So how many ports are there in PICSimLab? That we don't know. Before we connect this LED to the pin, we need to know which port we need to connect the LED. So how to know? So open MPLAB XIDE. So here we having data sheets. Click on it. Then so here search PIC16F877A, this one. Then click on the data sheet. So this one, right? So yeah, so here we having data sheet. Click it. So So what is data sheet? It is a technical document. So now search, Control F, search PIC16F877A. Not this one, not this one. Search the block diagram. So not this one. Keep search until you get the block diagram. So 1 second. So here we having, right? So PIC16F877A is not there. So here it is, PIC16F877A. How many ports are there? Port A, port B, port C, port D, port E. So 5 ports are there. So in port A we having 6 pins, port B we having 8 pins, here also 8, then here 3 pins. So but we don't know the LED is connected to which port of the microcontroller. So how to find this? And before that, this is the PIC16F877A microcontroller. Here you can see we having data bus and program bus. So which architecture it is? Separate buses. So this is Harvard architecture. And one more thing you need to remember, port A, port B, these are case sensitive. Don't use shortcuts, write as it is. And here we having 6-bit, 8-bit, 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 then 3 bits. So what is my question? LED is connected to which port, right? So how to find this? We'll get this we will know this by using the schematic diagram. So where we will get schematic diagram? Open the PICSimLab Simulator. So here in the PICGenios, so here help clipboard. So here you can see LED is connected to the port B and port D, isn't it? So here we having 16 LEDs. So these are connected to port D and these are connected to port B. So here you can see in the schematic diagram. So here it is connected to port D and port B. Okay, let's do this using the port B. So now go to the data sheet and here search port B. So here before that now here you can see about port B. So port B is 8-bit wide and it is bidirectional port, not unidirectional. Then the corresponding data direction register is TRISC-D. So DDR is TRISC-D. So you take any microcontroller, you have to set the direction of pins and set and to set that we having register, that is for port B we having tris B. So tris B, so what is, why B? Because that is port B. For tris X we having, for in this condition, so port B we having tris B, port A we having tris A, like that we having. So here you can see setting a tris B will make the corresponding port B pin an input. Clearing a tris B bit will make the corresponding pin an output. So we need to set the data direction pin. So tris B bit equals to 1, then corresponding port B is an input. So tris B bit equals to 0, then the corresponding port B is the output. So remember this, it is required to write the code. Okay, let's write the code, but before that we need to know the address of this bit. So how to find, search again port B or tris B. Then you will get the, yeah, so here you having address, right? So the address of tris B is 86H and address of port B is 06H. Now we got idea. So now let's write the code using these addresses. So can we write code like this? So here this is unsigned char is a data type, and here we using pointer, then port B equals to unsigned char, this is a address. So this is the address of port B and this is the address of tris B, and here we setting the pin direction as output. We saw in the data sheet, right? So like this, and here in this case LED turn on. So can we write like this? Yes. But is it possible to find address for, yeah, here this is a simple code, right? For blinking LED, turn on LED. Is it possible to write same thing for the complex code? So where we using LED, digital keypad, CLCD, everything. Is it possible to find the address and write the code? No, it's too difficult, right? So for that reason we will simplify the code like this. So here we using hash include xc8.h. So what it will do? Why it is using? Here we not using the address. So why? Because this will assigning the address. So we are using this header file. Now tris B equals to 0x00. So setting pin direction as output, and here port P equals to 0x55. So now LED will turn on. So this is the project creation. So every .c file should have .h file. So here you can see this main.h we included in the .c, and the initialization code should be here and application code should be here. So now if you write like this, can you guess this is LED code? So if I write code like this, can you guess this is LED code? No. So yeah, so don't consider this comment lines. I am saying only this. So we can't tell this is LED code. So for that reason, how to write the code? In the header file, we need to write port B. So here we connect it to LED. Then we need to use in the C, main.c. So how to write this? Let's write. Before that, okay. Before that, that will write in the next session. So before that, you need to install these 3 software and keep it ready with the next session. Okay. So this is the PICGenios board. So here see, we having 16 LED. So this is the LED array, and here we having keypad. So this is the digital keypad, and this is CLCD, cooler, we having buzzer, and this is the microcontroller IC. So here you can see. So all are there in the PICSimLab board. So you need to install these 3 softwares before going to the next class. Okay. So that's all about the today's session. Thank you all.